Awesome. So I'm Caleb. I work at GitButler, and we work on Git tooling. So we're currently building a new Git client, but rather than just wrapping the Git CLI, we're actually working to reinvent workflows, improve them, and provide better developer experience. And we're also branching out into things like code review and things like that. But today, I'm going to talk to you a little bit about sort of some of our core features, and I'm going to talk to you about some of the things we've been working on in terms of Git Rebase. So here are some of the core features that GitButler provides. It's pretty good. I like it. So one of our major features is that we allow you to work on multiple branches simultaneously. So this is not just stacking branches, but this is also working on multiple branches simultaneously within the working tree. So these are two independent branches that can be sort of merged independently of each other. We also support dragging and dropping changes into commits. So if you want to fix up a commit rather than doing something like a git commit -- fix up, you can just drag and drop a change onto a target commit and it will be amended for you. And every action that you perform in GitButler is undoable. So we've got this history that records every operation that you do, and you can go back to any point in time that you've previously been at within the application. We also take snapshots if you've done sort of lots of changes, so you can also go back if you've deleted half the project or something, which is more helpful than I'd like to admit. But today, the topic is going to be something that I've been working on for the sort of last month or so. So it's still under an experimental flag, but it's going to be released within the next week or so. So, rebasing. It's been in Git for over sort of 19 years now. This is the commit where it was first introduced into the project, and fundamentally, it's not changed. I mean, it's an incredibly powerful tool that powers a lot of the logic behind tools like GitButler and other sort of neo Git clients, but it's got some flaws. The big one is what happens if we both work on the same file at once. We get something like this, where it says, we have tried to merge this commit, but you've touched a file, a colleague's touched a file, and now there's a conflict. It stops the rebase in its track, and it dumps a bunch of conflict markers in your working directory, and you've got to go and resolve them. This is unfortunate for two reasons. The first of those is you've got to immediately go and resolve these conflicts. You can't, postpone it, do it later. But you also don't know, how many more of these conflicts are going to occur. Is it just one or two, or do I have 50 commits that I have to resolve? And it's going to be sort of a half-hour-long sort of conflict-resolving mission that you've got to go on. So, can it be better? Is the question that we ask ourselves at GitButler. Oh, typo there. So what I'm going to do is I'm going to go over some of Git's innards to give you sort of a primer on how some of Git works. I did try to AI generate a picture of the Git logo with blood and guts coming out, but apparently that was against content guidelines or something. So I instead asked it to create the Git logo with cranberry juice and sausages coming out of it, which was even less safe for work. So you got my clip art instead. So the three things that I'm going to cover in terms of Git innards is how Git stores files and folders, how Git actually merges together files, and how a typical rebase is going to work. Then I'm going to go over how GitButler is improving the rebasing workflow to make it fantastic. So, firstly, if you want to build your own VCS, which I don't recommend, the first thing you're going to need to do is track files, because that's what we write at the end of the day. And the way that Git represents files is it stores them in an object called a blob. And the way it does that is it takes the contents of a file. Firstly, the important thing is if you're storing files, you don't want to store duplicate copies of a file. You only want to store one of them in your object database, because otherwise you might have thousands of copies of the same file, which is never good. So what Git does is it takes the contents of that file and it appends a header to it. And that header is saying what type of object it is. So that would be, blob. And it also appends the length of the file. So Git knows how long the file it's actually storing is. And then it runs it through a SHA-1 hashing algorithm. And that sort of output of the hashing algorithm is where the object actually gets stored in the Git database. And the important thing about this is that if, say, a colleague, hashes the same file, it ends up with the same object ID. And whenever Git goes to store it, it says, actually, I already have a copy of this file. I don't need your new version. If you want to play around with objects in the object database, there's some commands that you can use to sort of explore these. The first one is git hash object, which you can pass it a file path, and it will take that file, perform the sort of hashing operations, and give you an output char. But by default, that's not getting written to the object database. So you can pass the -w argument, and it will actually write that to the object database for you. And then you can read it back using git catfile -p, pass it the blob ID, and you'll actually be able to read and write files from the object database. Now, with git catfile-p, you can actually pass it any sort of object that Git stores. So you can pass it a commit, which will then tell you some more information about what's inside the commit. And you can actually follow through and pretty much explore all of Git's internals using that mechanism. So that's really interesting. I enjoy doing that. But I know I'm a massive nerd, okay? But once you've got files stored in your version control, you probably want to store folders, because last time I checked, I was told off for writing 10 million lines in one file. So Git solves this problem by having a tree data structure. And unfortunately, it's not the green kind that you can water. This kind just actively destroys the planet. And I'm sure someone in Web3 has decided to try and store them on the blockchain as well, which made it even better. But Git has these tree data structures. And it's a list of these entries that are made up of several sort of components. So on the rightmost side there, you can see a component that looks an awful lot like a Unix file permission. And you're wrong. It is instead a bunch of numbers that Git uses to sort of determine the purpose of the object. And the only bit that is actually relevant in terms of file permissions there is actually the executable bit. This is why whenever you sort of push a bunch of files to Git, and then in the sort of tree entry, the next sort of piece of information that we've got is whether it's a blob, tree, or commit. So blobs are, this is a file here. Trees are, here's a subdirectory. And commits are, if you've done something wrong and started using submodules. That's from experience. Then we have the actual object ID that the tree entry is pointing to. So you could take any one of those object IDs, actually look it up and sort of open up the subdirectory or look at the contents of that entry. And then you've got the file name, which are sorted in alphabetical-ish order, because someone decided that when you're sorting these entries, if it's a folder, there should be an invisible / at the end of it before you do the sorting. But either way, once you've gotten over all of those quirks, you can then take this list, run it through a SHA-1 hashing algorithm, and it also gives you a similar object ID. And similar to the files, it will only store one copy of these tree objects, meaning that we avoid duplication. So even if you have sort of 2 copies of the same subdirectory, you actually only store 1 copy of the subdirectory in the Git object database, which is pretty cool. If you want to impress your colleagues and be like, oh, look what I can do, here are some commands that you can run. So git catfile-p again, fantastic command. Pass it anything in Git, prints it out for you. I recommend sort of just passing everything that you receive into that. It's a great time. Then there's git lstree, which basically does the same thing, but it's sort of tree specific and has some utilities around that. And sort of specifically one that I quite like is doing git lstree -r, which will recursively go through any subtrees. So if, for example, you want to see sort of all the uncommitted files that are in your repository, you can run git lstree -r and pass it the word head, and that will just print out all of the committed files in your repository, which is pretty cool. But now we've got sort of storing files in our version control software, we probably want to be able to combine them with our colleagues' work. And this is a bit of a problem, because let's say on the left side you've got some changes to our testing framework that I've written, and on the right we've got some changes that Matthias has made. And in blue, I've highlighted the changes that sort of I've maybe have made, and Matthias maybe has made, but all I really know is that there are differences on these lines. It's actually impossible to tell whether I changed, say, the word square from the word round, or if both of us changed these sort of words from the letter I to something more descriptive. So Git employs a mechanism called a three-way merge to help it get a better understanding of who made what changes. So with a three-way merge, it employs the use of a common ancestor to diff the sort of left and the right side against. So here we're able to see I've made those changes highlighted in green against the common ancestor, and Matthias has made the changes highlighted in orange. Using this information, Git is able to assert that only Caleb has touched the top paragraph, so it's probably safe to merge those together automatically. And those bottom two paragraphs, we don't actually know what changes we want, so this is where Git says, hang on a second, something's gone wrong, please fix it for me. So once we've got files stored in our file system, we've got a way of merging things together. We can now talk about the bog standard rebase, how Git does it out of the box. So let's say I've got a branch. I'm making some commits off of the main branch. So I've got commits A, I've got commits B. And my colleagues have done some other work on origin main. They've pushed it to the upstream, and I'd like to incorporate those changes into my branch. What I can do is I can run this command git rebase origin main, and the first thing that command does is it goes and determines what commits have I written that aren't part of origin main. And in this instance, it'll be able to figure out it's the A commit and the B commit that need to be added onto the top of origin main. And to do this, it does just a series of these three-way merges. So it starts off with the bottom of the commits that I've written. So in this case, that's the A commit. And it takes that as the left side of our three-way merge. It then takes origin main as the right side of the three-way merge. And then it takes the parent of the A commit as that common ancestor. And assuming all goes well, it will write out a new A commit that is on top of origin main. And it will continue doing that. So it'll then take my B commit, the new A commit, and the common ancestor, which is the parent of the B commit, and it'll keep merging these together. If you've got 50 commits, it'll keep running through this process unless there's a conflict. And it's this conflicting scenario that we wanted to try and improve. So I'm now going to go through what GitButler does in the scenario where we actually detect a conflict. So we've branded this fearless rebasing because you can now rebase with no worries at all, unless I've made a bug or something, but it doesn't happen. So if I have a conflict between A and origin main, typical Git says, please fix this for me. It throws a code 1 or something in your terminal and you've got to go sort it out. But with fearless rebasing, what we instead do is we write a special type of commit which we've marked as conflicted. Now, this conflicted commit has, rather than just a standard tree, we actually write our own tree, which has 4 subdirectories. Now, the first 3 subdirectories are just recording what are the trees that we were trying to run the three-way merge on. And this is important so we can reconstruct the three-way merge later, so you can, at your leisure, go and resolve it. We then go and make this auto-resolution tree, which is where we've gone and sort of merged together the we've gone and merged together the commits, and we've done a best effort to try and pick, what is the best outcome of this merge if we were to resolve it for you. And making use of this auto-resolution, we're actually able to complete the entire rebase operation. And the benefit of this is that, firstly, it will always succeed. And secondly, you can see what commits are actually going to get conflicted. So I've made a little scenario here. So with GitButler, if I have this branch here, which I've decided to make the marketing website bright pink, decided our designer was wrong about the whole teal decision, and I've got 4 commits. Now, my colleague has made some changes that have been introduced into origin main, and it turns out that he's touched the header code, which is also part of my branch. It should be, and that has come up as these conflicted commits. It should be noted here that currently we say 0 files changed here, but this is still work in progress, and this will list out all the conflicted files whenever I get back to work on Monday. But the great thing about this is I can see this is what's conflicted, this is what I need to resolve, and I can also do it at a later date. So I can, go make a cup of coffee, do some other work, and then come back to it, which is fantastic. It means we can stay up to date, integrated, much more easily. But let's say I do want to resolve one of these conflicts. I can go ahead, hit the Resolve Conflicts button, which opens up our edit mode view. This is a special mode which checks out that commits changes and allows you to manipulate them. And for a conflicted commit, it does as you would expect, and it just outputs the conflict markers into your working directory for you to go and resolve. So you can use sort of fancy VS Code buttons to do that. If you know what they do, I just resolve it manually because that's easier. And then GitButler will say, this is all good now, and you can save the changes, and the commit's resolved. Now, in this case, the scenario that I made ended up just resolving the bottom commit, but in a lot of cases, if you resolve one conflicted commit, oftentimes it cascades up as well. But that sort of depends on the scenario. But either way, we've been able to do it piecemeal and be able to see, what changes are affected. So if you've enjoyed this, feel free to check out GitButler. It's free to download, free to use. And check us out on GitHub. We're source available. So if you're keen to see any of the implementation details, feel free to go take a look. And if you've got any questions, feel free to come talk to me afterwards. I'd love to chat about this. My email's also there if you want to send me emails and pester me about this as well. So thank you for listening.
We have some time for questions before we break to lunch.
Ooh.
So
Go for
that was a quick hand. Let's go for that one.
Yeah, and I apologize for my question, but you at the beginning you showed this command git hash object, and I just wanted to ask if it can hash other things than just files.
So git hash object is specifically for hashing files to be stored into the Git database. Mm-hmm. If you're wanting to write a tree with the Git CLI, the options that you have are to add the files you want to your Git index using git add, and then there's a command, I think, git write tree, which actually will write the tree to the database.
So my follow-up question is, why isn't it called git hash file? Sorry.
Because Linus was drunk at the time or something.
Thank you.
I don't ask me. Again, this is sort of code that was in a VCS that was written over 2 decades ago. So, yeah.
Other questions?
When you showed the special trees that are written when you rebase,
yes,
you mentioned the automatic best effort one.
Yeah.
How does that work?
So the automatic best effort will try and do the three-way merge, but anytime it sees that both you and a colleague have tried to change a file, it will always prefer the sort of hours side. So in this case, it would be sort of what's part of origin main. So a lot of the times this resolves to code that is perfectly valid and working. Occasionally, of course, it won't, in case there's been like drastic changes, but it tends to be a good enough effort that you're still able to work in 95% of the time. I've been sort of driving this over 2 weeks, and yeah, it works out pretty well.
Does this approach also support like alternative merge strategies? Like I've seen this weird semantic diffing stuff that's helpful.
So I'm keen to talk to you more about your use case. At the minute, we're primarily focused on a trunk-based development workflow. So we support sort of the rebasing operations, things like reordering commits. In terms of merging in changes, we've got the ability to write a conflicted merge commit as well that you can resolve at your leisure. But currently in GitButler, the only merge commit you can actually create is if you're merging origin main into your branch with a merge commit. But in the future, definitely it will be possible to make merge commits that are like crisscross merges or things like that.
So, like, this is for if another developer changes the files I changed. Like, in larger teams, this doesn't happen so much for me. But what happens all the time for me, and I've worked at big tech, and they've kind of fixed this idea of like, there's a big feature, so I want to review early, so I send it off to review, but the review takes ages, and then I keep stacking up, and I like to have a train of, PRs going in, but then after my first PR's merged, and that has to be like properly merged, because and then I start conflicting with myself, right? And I've seen, it's unique to Git, this problem of the, like, does it help with that situation?
So this certainly helps with sort of giving you confidence to keep your code, constantly on top of other changes. We're currently working on sort of stacking workflows and sort of, working with merge queues and that sort of thing. So I'd be kind of interested to talk more about your use case. We've primarily been sort of testing this, dog fooding this on our sort of medium-sized repository, and we've had usage on some larger repositories of sort of companies with much more developers. But I'd be keen to talk to you about how you might want this to work in like massive enterprise type scenario.
With this special tree that you just have open on the slide conveniently, do you have like any plans to potentially upstream that format like into Git itself, so that like you can also use it with other clients?
That would be a fantastic long-term goal. So last week we were at the Git Merge conference that we actually hosted, and we were talking about this with a bunch of the Git maintainers. And there was definitely interest in, at the very least, having a shared language that clients like GitButler, JJ, and Sapling can talk. So like we can have these clients that communicate. I think it would be a fantastic goal to eventually have something upstreamed, but I would say expect to see that in about 25 years' time, because that would be a monumental effort.
Thank you, this is great. It's commonly said that Git is a great data structure with bad usability, and I'm glad you're kind of tackling that part. I'm wondering though about the data structure part. Is there something you would like to, if you were to do Git again, is there something you would change about the data structure?
So with Git, you've got to be very careful that your objects don't get garbage collected. So if I was to write a bunch of random blobs or a bunch of random trees to the object database, eventually, if they're not referenced by a commit or by a reference, they get cleaned up. So at the minute, our best approach is to write out these subtrees. But if we were to instead have these as Git headers, which would probably be the preferable thing to do, would need some way of preventing them from getting garbage collected eventually. So long term, I think it would be a good move to sort of have the auto resolution be the actual commit tree and then have the others referenced in commit headers. But that's currently not particularly feasible at this point in time.
The one question, that it's kind of iteration on, again, on this tree and on continuing workflow. So when you first do this rebase, you're going to have this after resolution. And then you're going to repeat this rebase with probably new commits that's going through the master. Will this automatic conflict resolution still be in place, or just going to be replayed over and over again?
So you're able to treat these conflicted commits just like regular Git commits within the GitButler client. So you're able to reorder them, amend. You can't amend to them, sorry, but you're able to rebase them. So if I've got a bunch of conflicted commits, I could go and actually rebase on further upstream changes and keep them up to date like that. So yeah, that's completely possible.
Any other questions?
All right.